In this lesson, you will learn about the fundamentals of FortiGate High Availability, HA, and how to configure it. FortiGate HA provides a solution for enhanced reliability and increased performance. In this lesson, you will learn about the topics shown on this slide. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in HA operation modes and primary FortiGate election, you will be able to choose and implement the right HA operation mode in your network based on your requirements. FortiGate HA uses FGCP to discover members, elect the primary FortiGate, synchronize data among members, and monitor the health of members. FortiGate HA links and synchronizes two or more FortiGate devices to form a cluster for redundancy and performance purposes. A cluster includes one device that acts as the primary FortiGate. The primary sends its complete configuration to other members that join the cluster, overriding their configuration, except for a few settings. It also synchronizes session information, forwarding information base, FIB entries, FortiGuard definitions, and other operation-related information to the secondary devices, which are also known as standby devices. The cluster shares one or more heartbeat interfaces among all devices, also known as members, for synchronizing data and monitoring the health of each member. There are two HA operation modes available: active-active and active-passive. Now you will learn about the differences. In active-passive mode, the primary FortiGate is the only FortiGate that actively processes traffic. Secondary FortiGate devices remain in passive mode, monitoring the status of the primary device. In either of the two HA operation modes, the operation information, sessions, FIB entries, and so on, of the primary FortiGate is synchronized with secondary devices. If a problem is detected on the primary FortiGate, one of the secondary devices takes over the primary role. This event is called an HA failover. If a secondary FortiGate device fails, the primary updates its list of available secondary FortiGate devices. It also starts monitoring for the failed secondary, waiting for it to come online again. The other HA mode is active-active. Like active-passive HA, in active-active HA, the operation-related data is synchronized between devices in the cluster. Also, if a problem is detected on the primary device, one of the secondary devices takes over the role of the primary to process the traffic. However, one of the main differences from active-passive mode is that in active-active mode, all cluster members can process traffic. That is, based on the HA settings and traffic type, the primary FortiGate can distribute supported sessions to the secondary devices. If one of the secondary devices fails, the primary also reassigns sessions to a different secondary FortiGate. To successfully form an HA cluster, you must ensure that the members have the same model, hardware model or VM model, firmware version. Licensing includes the FortiGuard license, virtual domain VDOM license, FortiClient license, and so on. Hard drive configuration, the same number and size of drives and partitions. Operating mode, the operating mode, NAT mode or transparent mode of the management VDOM. VDOMs divide a FortiGate device into two or more virtual units, essentially dividing one physical firewall into additional logical devices. If the licensing level among members isn't the same, the cluster resolves to use the lowest licensing level among all members. For example, if you purchase FortiGuard web filtering for only one of the members in a cluster, none of the members will support FortiGuard web filtering when they form the cluster. From a configuration and setup point of view, you must ensure that the HA settings on each member have the same group ID, group name, password, and heartbeat interface settings. Try to place all heartbeat interfaces in the same broadcast domain, or for two-member clusters, connect them directly. It's also a best practice to configure at least two heartbeat interfaces for redundancy purposes. This way, if one heartbeat link fails, the cluster uses the next one, as indicated by the priority and position in the heartbeat interface list. In the example shown, port 3 would have a priority of 10, and port 4 would have a priority of 20, making port 4 the preferred interface. If you are using DHCP or point-to-point protocol over Ethernet (PPoE) interfaces, use static configuration during the cluster initial setup to prevent incorrect address assignment. After the cluster is formed, you can revert to the original interface settings. This slide shows the different criteria that a cluster considers during the primary FortiGate election process. The criteria order evaluation depends on the HA override setting. This slide shows the order when the HA override setting is disabled, which is the default behavior. Note that the election process stops at the first matching criteria that successfully selects a primary FortiGate in a cluster. 1. The cluster compares the number of monitored interfaces that have a status of up. The member with the most available monitored interfaces becomes the primary. 2. The cluster compares the HA uptime of each member. The member with the highest HA uptime by at least 5 minutes becomes the primary. 3. The member with the highest priority becomes the primary. 4. The member with the highest serial number becomes the primary. When HA override is disabled, the HA uptime has precedence over the priority setting. This means that if you must manually failover to a secondary device, you can do so by reducing the HA uptime of the primary FortiGate. You can do this by running the diagnose sys HA reset uptime command on the primary FortiGate, which resets its HA uptime to 0. Note that the diagnose sys HA reset uptime command resets the HA uptime and not the system uptime. Also note that if a monitoring interface fails or a member reboots, the HA uptime for that member is reset to 0. This slide also shows how to identify the HA uptime difference between members. The member with 0 in the uptime column indicates the device with the lowest uptime. The example shows that the device with the serial number ending in 92 has an HA uptime that is 7,814 seconds higher than the other device in the HA cluster. The Reset CNT column indicates the number of times the HA uptime has been reset for that device. If the HA override setting is enabled, the priority is considered before the HA uptime. The advantage of this method is that you can specify which device is the preferred primary every time, as long as it's up and running, by configuring it with the highest HA priority value. The disadvantage is that a failover event is triggered not only when the primary fails, but also when the primary is available again. That is, when the primary becomes available again, it takes its primary role back from the secondary FortiGate that temporarily replaced it. When override is enabled, the easiest way of triggering a failover is to change the HA priorities. For example, you can either increase the priority of one of the secondary devices or decrease the priority of the primary. The override setting and device priority values are not synchronized to cluster members. You must manually enable override and adjust the priority on each member. Good job! You now understand HA operation modes and the election of the primary FortiGate in an HA cluster. Now you will learn about HA cluster synchronization. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in cluster synchronization, you will be able to identify the tasks assigned to members based on their roles, as well as what information is synchronized between members. So, what are the tasks of a primary FortiGate device? It monitors the cluster by broadcasting hello packets and listening for hello packets from other members. The members use the hello packets to identify whether other FortiGate devices are alive and available. The primary FortiGate also synchronizes its operation-related data to the secondary members. Some of the data synchronized includes its configuration, FIB entries, DHCP leases, ARP table, FortiGuard definitions, and IPsec Tunnel Security Associations, SAs. Note that some parts of the configuration are not synchronized because they are device-specific. For example, the host name, HA priority, and HA override settings are not synchronized. Optionally, you can configure the primary FortiGate to synchronize qualifying sessions to all the secondary devices. When you enable session synchronization, the new primary can resume communication for sessions after a failover event. The goal is for existing sessions to continue flowing through the new primary FortiGate with minimal or no interruption. In active-active mode only, a primary FortiGate is also responsible for distributing sessions to secondary members. Now, take a look at the tasks of secondary FortiGate devices. Like the primary, secondary members also broadcast hello packets for discovery and monitoring purposes. In addition, in active-passive mode, the secondary devices act as a standby device, receiving synchronization data but not actually processing any traffic. If the primary FortiGate fails, the secondary devices elect a new primary. Once a cluster is in sync, configuration changes made on a secondary device are propagated to other members. In other words, with a cluster that is in sync, you can make changes on any of its members, not just the primary device only, and all changes are synchronized among the cluster members. However, it is recommended that you make configuration changes on the primary device because this prevents the loss of configuration changes if there are synchronization issues between cluster members. In active-active mode, the secondary devices don't wait passively. They process all traffic assigned to them by the primary device. To prepare for a failover, an HA cluster keeps its configurations in sync. FortiGate HA uses a combination of both incremental and complete synchronizations. When you add a new FortiGate to the cluster, the primary FortiGate compares its configuration checksum with the new secondary FortiGate configuration checksum. If the checksums don't match, the primary FortiGate uploads its complete configuration to the secondary FortiGate. After the initial synchronization is complete, whenever a change is made to the configuration of an HA cluster device, primary or secondary, incremental synchronization sends the same configuration change to all other cluster devices over the HA heartbeat link. An HA synchronization process running on each cluster device receives the configuration change and applies it to the cluster device. For example, if you create a firewall address object, the primary doesn't resend its complete configuration, it sends only the new object. HA propagates more than just configuration details. Some runtime data, such as DHCP leases and FIB entries, are also synchronized. By default, the cluster checks every 60 seconds to ensure that all devices are synchronized. If a secondary device is out of sync, its checksum is checked every 15 seconds. If the checksum of the out-of-sync secondary device doesn't match for 5 consecutive checks, FortiGate performs a complete resynchronization of that secondary device. Not all the configuration settings are synchronized in HA. There are a few that are not, such as System Interface settings of the HA Reserved Management Interface and the HA Default route for the Reserved Management Interface. in-band HA management interface, HA override, HA device priority, virtual cluster priority, FortiGate hostname, HA priority setting for a ping server or dead gateway detection configuration. All licenses except FortiToken licenses, serial numbers. Cache. GUI dashboard widgets. Good job! You now understand HA cluster synchronization. Now you will learn about HA cluster failover protection types. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in failover types, you will be able to identify how enhanced reliability is achieved through HA failover protection. The most common types of failovers are device failovers and link failovers. A device failover occurs when the secondary devices stop receiving hello packets from the primary. A link failover occurs when the link status of a monitored interface on the primary FortiGate goes down. You can configure an HA cluster to monitor one or more interfaces. If a monitored interface on the primary FortiGate is unplugged or its link status goes down, a new primary FortiGate is elected. When you configure Remote Link Failover, FortiGate uses the Link Health Monitor feature to monitor the health of one or more interfaces against one or more servers that act as beacons. The primary FortiGate fails if the accumulated penalty of all failed interfaces reaches the configured threshold. If you enable memory-based failover, an HA failover is triggered when the memory utilization on the primary FortiGate reaches the configured threshold for the configured monitoring period. You can also enable SSD failover, which triggers a failover if FortiOS detects EXTFS errors on an SSD on the primary FortiGate. There are multiple events that might trigger an HA failover, such as a hardware or software failure on the primary FortiGate, an issue on one of the interfaces on the primary, or an administrator-triggered failover. When a failover occurs, an event log is generated. Optionally, you can configure the device to also generate SNMP traps and alert emails. Enabling session pickups allows active sessions to be seamlessly picked up by the new primary in the event of an HA failover. In other words, users' sessions will continue uninterrupted, and they will not even know that a failover occurred. Note that there are some limitations to this. For example, any sessions that terminate at the FortiGate itself, example SSL, VPN, proxy sessions, cannot be handed off to another FortiGate and must be restarted on the new primary. To forward traffic correctly, a FortiGate HA solution uses virtual MAC addresses. When a primary joins an HA cluster, each interface is assigned a virtual MAC address. The HA group ID, virtual cluster ID if enabled, and interface index number are used in the creation of virtual MAC addresses assigned to each interface. So if you have two or more HA clusters in the same broadcast domain and using the same HA group ID, you might get MAC address conflicts. For those cases, it is strongly recommended that you assign different HA group IDs to each cluster. Through the heartbeats, the primary informs all secondary devices about the assigned virtual MAC address. Upon failover, a secondary adopts the same virtual MAC addresses for the equivalent interfaces. The new primary broadcasts gratuitous ARP packets, notifying the network that each virtual MAC address is now reachable through a different switch port. Note that the MAC address of a reserved HA management interface is not changed to a virtual MAC address. Instead, the reserved management interface keeps its original MAC address. Good job! You now understand HA failover. Now you will learn about monitoring an HA cluster. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in monitoring FortiGate HA, you will be able to verify its operational status and make changes to suit your business and security requirements. The HA page on the FortiGate GUI shows important information about the health of your HA cluster. For each cluster member, the page shows whether the member is synchronized or not and its status, hostname, serial number, role, priority, uptime, active sessions, and more. On the HA page, you can remove a device from a cluster. When you remove a device from HA, the device operation mode is set to standalone. You can also enable more columns that display other important information about each member, such as the checksum, CPU, and memory. You can also add the HA status widget on the dashboard page. The widget provides a summary of the HA status on the device. You can get more information about the HA status on the FortiGate CLI by using the Get System HA Status command. The command displays comprehensive HA status information in a user-friendly output and is usually executed as the first step when troubleshooting HA. This slide shows the first part of an example output that the command provides. At the beginning of the output, you can see the cluster status, the member model, the HA mode in use, and the cluster uptime. The example output shows that the cluster status is good, the member model is FortiGate VM64-KVM, and the HA mode is active-passive. Next, you can see the latest primary election events, the result, and the reason. The configuration status information is displayed next. It indicates the configuration sync status for each member. For both members, the configuration is in sync. Following the configuration status information, you can see the system usage statistics, which report on performance statistics for each member. They indicate the number of sessions that each member handles, as well as the average CPU and memory usage. Note that the Sessions field accounts for any sessions that the member handles, and not only the sessions that are distributed when the HA mode is active-active. This slide shows the second part of the example output that the Get System HA Status command provides. The output begins with the status information for the configured heartbeat, monitored, and remote link interfaces. These interfaces enable the cluster to perform device failover, link failover, and remote link failover protection, respectively. Next, the output shows the role, hostname, serial number, and ID information for each member of the cluster. The output indicates that the NGFW1 and NGFW2 devices are primary and secondary members, respectively. The Diagnose Sys HA Checksum command tree enables you to check the cluster configuration sync status. In most cases, you should use the Diagnose Sys HA Checksum cluster command to view the cluster checksum. The output includes the checksum of each member in the cluster. When you run the Diagnose Sys HA Checksum cluster command, the checksum is pulled from each member using the heartbeat interface. If HA is not working correctly, or if there are heartbeat communication issues, then the command may not show the checksum for members other than the one on which you run the command. An alternative is to connect to each member individually and run the Diagnose Sys HA Checksum show command instead, which shows the checksum of that member. After you obtain each member's checksums, you can identify the configuration sync status by comparing them. If all members show the exact same hash values for each configuration scope, then the configuration of all members is in sync. To calculate checksums, FortiGate computes a hash value for each of the following configuration scopes. Global. Global configuration, such as global settings, FortiGuard settings, and so on. Root. Settings and objects specific to the root VDOM. If you configure multiple VDOMs, FortiGate computes hash values for each VDOM. All. global configuration plus the configuration of all VDOMs. In some cases, the configuration of members is in sync, even though the checksums are different. For these cases, try running the diagnose sys HA checksum recalculate command to recalculate the HA checksums. When FortiGate devices form an HA cluster, the primary device synchronizes most of its configuration to the secondary device, including the interface settings. From that point, each cluster member will have the same IP address configured on each interface, but only the primary member will respond on the network. As a result, the secondary devices will not be reachable over the network for administrative access, SSH, HTTPS, SNMP monitoring, or any other purposes. If you cannot access the secondary cluster member, how can you configure the dedicated IP on it, or anything else for that matter? You can accomplish this by first connecting to the primary FortiGate CLI via SSH and then running the execute HA manage command, as shown on this slide, to tunnel into the secondary device's CLI via the primary device. This command requires you to indicate the secondary device's member ID, which can be obtained by typing a question mark at that point in the command. See screenshot. You will also need to provide the username of an administrator account in the command. If the connection is successful, you will be prompted for the administrator password. Once you are connected to the secondary device's CLI, you can enter CLI commands normally to configure or view whatever you wish. Type exit to close the connection to the secondary member and return to the primary member's CLI prompt. When you connect to a cluster using any of its virtual IP addresses, you always connect to the primary. You can then switch to the CLI of any member in the cluster by using the execute HA manage command. But what if you want to access the GUI of a secondary member, or maybe pull data from it using SNMP? For this, you need a way to access each member directly, regardless of its role in the cluster. FortiGate provides two ways for the administrator to connect to a member directly, no matter what the member role is. The reserved HA management interface is the out-of-band option. You can configure up to 4 dedicated management interfaces, and you assign them a unique address on each member. You can then use the unique address assigned to each member to connect to them directly. You can also instruct FortiGate to use the dedicated management interface for some outbound management services, such as SNMP traps, logs, and authentication requests. Alternatively, you can configure in-band HA management, which enables you to assign a unique management address to a member without having to set aside an interface for that purpose. You assign the management address to any user traffic that the member uses, and then connect to the member using that unique management address. If you have unused interfaces, then it's generally more convenient to use a reserved HA management interface because the user and management traffic don't have to compete. Many FortiGate models come with a management interface that you can use for this purpose. Also, the routing information for a reserved HA management interface is placed in a separate routing table, which means that you don't see the interface routes in the FortiGate routing table. This allows for segmentation between data and management traffic. This slide also shows configuration examples for both management options. For both options, the configuration you apply on a member is not synchronized to other members in the cluster. Congratulations, you've completed this lesson. Now you will review the objectives covered in this lesson. This slide shows the objectives that you covered in this lesson. By mastering the objectives covered in this lesson, you learned about the fundamentals of FortiGate HA and how to configure it.